Okay, Scholar Practitioner Leaders, SPLs, Data Scientists, we are now back for our week 2 for our lecture 3 of 4. Now, I want to piggyback on our previous lecture 2 of 4, where I was speaking on section 2 of 3. Now, I was speaking on the second area that we're going to be focusing on for our drills with an R on importing and plotting data. Okay, so this is very instrumental. So I want to make sure that we have clear transparency on step 2. Now, on step 2, we're going to be looking at, again, from that murder data file. I know, guys, the murder data file, right? But that's great data, even though it was back in 2017. We still want to be able to extrapolate the data. And where I was at, and this is coming from Washington, D.C., right? So the crime reports, our government does a great job keeping up with various types of data. So, what better place to resource data for us data scientists than Washington, D.C.? So, I want to piggyback on, again, number 2. Let's look at actually letter A. Okay, so there's 3 areas. Now, as I was mentioning in letter A, you're going to find the mean and the standard deviation and interpret their overall values. That was letter A. Now, this is where we left off at on letter B. We got to find the 5-number summary and construct the corresponding box plot, right? So we know about that. But then here's the letter C piece, right? Now we got to include the observation for DC. What is the affected and more by this outlier? Okay, so I want to make sure that we're crystal clear on that. You're going to have to make sure to include the overall observation for DC and what is the affected more by this outplot, the mean or the median. So you're going to tell me which one that you think, based on the box plot and the data, that's more affected. Now, and then thirdly, for our drills within our assignment, you're going to also look at the houses, okay, data file. There's 2 data files I want you to look at from, as you saw, guys, in week 1. It was 2 files. It was the murder data file and then the houses data file for this drills within our assignment. And then, like I said, guys, the good thing is when I saw your work, man, you guys nailed it. So I'm really, really, really happy, as I mentioned in previous lectures, where you guys are really having fun. And that's what I mentioned in last week's lecture. This course is really fun because as data scientists, we really engulf ourselves into data. When it comes to data, if we have a way to grab some data, we're going to extrapolate it. We're going to do our deductive reasoning and we're going to do our inferencing based on the outputs from the data. So what better thing to do as data scientists, and especially if Dr. Mark is providing me with the data, you guys with the data, right? Than to extrapolate data and then get our deductive reasoning from it. That is truly a win-win. And then, like I saw from your assignments, everybody was truly having fun with that. So I'm really happy about that. But again, the third area of the 3 that I wanted to look at was the housing data file, the houses data file. And then all you had to do, to me, what I wanted to see was, I wanted you to look at the overall selling prices, thousands of dollars, right? And it was all about the overall size and square feet, the tax bills in dollars, and the number of bathrooms, number of bedrooms, all the demographics when you're talking about a house. Whether the house is new, either yes, which is going to be like number 1, or 0, which is going to be no, which was no. And then the for the 100 home sales in Gainesville, Florida. So all you had to do was actually just, again, was analyze the selling prices. So that was really, really fun, guys. And I really hope you enjoyed that. So there was 3 things from that part 3 that I want you to do. Again, you have to construct a frequency distribution, this time as a histogram. Okay, so you have to do the frequency distribution. Instead of doing a block plot, I wanted a histogram, right? So, and then secondly, you had to find the percentages of observations that fall within the standard deviation of the mean. So pretty straightforward. And then thirdly, you had to construct the therefore mentioned box plot. So you had to do the box plot in section 2, as well as do a box plot for now. Well, you had to do the first box plot in regard to murder in the capital city of Washington, D.C. back in 2017. Had to do that initial box plot. Then I gave you a second opportunity to do a box plot again for the housing pricing distribution. So when you constructed that box plot, I'm sure it was pretty second nature now. So, and that was it. So, and then I provided you that overall data sets for you. So life was good. You had that indexes of data sets for you. And those was all about basing it on the using the R tool. So that was your drills with an R assignment. And then the second assignment that I gave you in week 1 was, well, actually, it's the third assignment, right? But the third assignment was all about the quality issues, the data quality issues. And that was your initial project 1 that I gave you. So I'm hoping that you guys like the third assignment, okay? And that was all about being mostly based on issues with data quality. Then you had to see how that all intertwined with chapter 2, data and sampling distributions from practical statistics for data scientists, which was all covered in the book in those respective sections, 2.5 and then 2.6. Now the page number could be a little skewed, guys. And all you gotta do is find a section, so that's minor. And as always, page numbers do tend to be different from the actual figure, and that's because they come out with new editions every year or every other year. Okay, so as long as you found the figures, and I had a couple of emails on that, the figures, the page number sometimes don't line up, and that's minor. So okay, so as long as you found the figures 2.5 and 2.6, and everybody did, it's pretty straightforward. But again, I did have a couple of emails, which is never a problem. I love receiving emails from you guys. Okay, and then so the second thing for this data quality issues was you had to discuss the following. How can you actually tell if the data is an outlier or is it actual something that's very important? So either an outlier or is it important? Or is both the outlier and the actual data, are they both important? So you have to come up with a way of differentiating that, okay? And then the second thing was I want you to tell me which data is the noise and how is the noise different from an outlier. So pretty much the same but different. So always remember that, guys. So it could be the same, but it could be different, or is it both? So that's what I want you to differentiate that for me and really explain it. And reading you guys' work, good answers, good answers, good answers. You guys are getting it. And then thirdly, from this data quality issues project 1 assignment, you had to also go into telling me about missing values. So the thing was, when there are actually missing values, right? Explain the pros and cons of the following types of strategies. So it was 2 strategies I want you to really extrapolate, was the elimination of data objects and, as I mentioned last week, the elimination of missing values, okay? And then fourthly, I gave you one summation question that I want you guys to give me a really reputable answer from. Number 4 was, what are the limitations of analyzing real data, as I mentioned last week, with missing values, and why is it impossible to really know such data? So, and that was it. So just give me a great answer on that. And I've read everybody's answers. You guys are truly becoming statisticians. Good job. So good answer on that, guys. Good work, good work. And as you see, there's nothing about APA formatting. Again, that's you guys' discretion. I always just highly recommend that. And it gives you structure as you do your assignments moving forward. And you providing credence on people who came before you. That's the good thing about using APA citations, guys, in-text citations. You're always advocating people who came before you. That's why you're giving that source credibility, again, from people who expounded on areas such as this, and you're pretty much validating same thing or something that they did before you. And that's always good from a scholarly perspective. Okay. All righty. So that's your assignments last week from week 1, guys. I just want to close that out. So now in our lecture 3 and 4, let's go over our week 2's work and assignment. So our overview. So let's go over the week 2 overview and our learning materials. And then we'll, on our last lecture, we will actually go into the week 2's assignments. Okay. So for this week 2, and you guys are really going to enjoy it because the good thing about our weeks, they always piggyback off of each other. So that's why I've always tell you, make sure you take great notes, because by taking these notes, it's all it's going to do is carry over, and that way you don't have to kill your brain cells trying to remember, because remembering sometimes, guys, you can remember for a while, but sometimes it kind of gets clouded, right? So if you take good notes, that will trigger that memory, like, oh, yeah, that's why we did go over that, blah, blah, blah. I got great notes. Here it is. Yep, now I remember it's coming back to me. I'm remembering, I'm always remembering. So it's always good to take great notes because it's truly advantageous, okay? Now, for our week 2, the overview is it's all about exploratory data analysis, which involves examining correlations among predictors and between predictors and target variables. So also in a big data project, predictive models are typically developed and piloted with samples. So samples are also in tests of various different sorts and extrapolation. So and as well as exploration. So just remember that, guys, when you're doing your overall samples, how it truly is, it's in various sorts when it comes to overall exploration. So major concepts discussed in this part are all about data and sampling distributions. This part meaning for week 2. And then also we're going to be looking at not only just random sampling, but also sample biases, sample mean versus population mean, and what is called the bootstrap. You guys are really going to like that when you read up on that, and I'll talk about that shortly. Okay, so sometimes data is generated from a physical process that is really modeled in these cases. So the overall perspective of it is that we can actually gain additional insight by using our understanding of the therefore mentioned populations. Okay. So probably the most popular model of distribution, if you don't know, is typically normal distribution. As we as data scientists, we're going to see, we're always talking about the bell curve, normal distribution. That is truly the most popular type of distribution. Okay. So that's your overview for week 2, guys. And if you want to go back and reread that and really comprehend it and dissect it even more, it's always in your current week's content. So when I give you the overview, I'm just reiterating what I've already put out there for you in our content folder for week 2. So feel free to always go back and reread that to make sure you got that down in your pocket to a science, figuratively and literally, data scientists. So the overall module objectives for this week. So by the end of the week, you'll be able to do 6 things again. You'll be able to calculate correlations, number 1. 2 of 6, you'll learn the proper procedure of random sampling. Number 3, you're going to be able to recognize different types of biases, okay? And that's going to be huge, guys, because there's so many types of biases. You need to be able to differentiate those, okay? I'm looking for your differentiation skills. Knowing how to differentiate biases is going to be huge because there's multiple types, okay? All right, number 4, learn the procedure for bootstrapping. So that's another thing that's going to be big in this upcoming week. You're going to really enjoy bootstrapping and what that's all about. And then number 5, learn about the meaning of confidence intervals, okay? Understanding what confidence intervals mean and what it's really all about. And then the last but not least, the 6 items, 6 of 6, you're going to be able to actually define the characteristics of the therefore mentioned normal distribution. Okay. So those are my key objectives for this week. And really, guys, take your time. Make sure you really, really get that, guys, because understanding those objectives when you read the ensuing chapters that I'm going to talk about is all going to coincide with this lecture. So when you have this